Over the past decade, integrated graphics processing units have undergone a quiet yet significant transformation. They were once primarily responsible for basic display output, but these small components, which are directly embedded within the CPU, have evolved considerably. They are now capable of handling tasks that previously required a dedicated GPU, which is why modern APUs have become increasingly popular amongst PC gamers. The upcoming Intel Nova Lake S is following the same path and is not merely an incremental upgrade. The alleged integration of two distinct GPU architectures on Nova Lake S makes it a complete game changer. In this video, we will talk about why this matters and how this innovative approach can help Intel to finally regain the lost CPU market share. Traditionally, iGPUs have been well suited for everyday computing tasks such as web browsing, office applications, and multimedia consumption. They now also provide a satisfactory experience for light and entry-level gaming with less demanding titles. However, their limitations became obvious with more intensive graphics workloads because their reliance on shared subsystem memory can lead to performance bottlenecks. While this challenge still remains, both AMD and Intel have made quite good advancements in recent years in strengthening their integrated graphics solutions. AMD, being still at the forefront in this sector, has been quite successful with its APUs, but Intel's entrance with its advanced iGPU architectures did shake up the market quite a bit. This is evident through the integration of Intel's Xe-based iGPUs into gaming handhelds such as MSI Class 7 and 8, but the company still lacks a dedicated APU series for the desktop. While it did deliver powerful APUs for the mobile platforms such as the Xe2-based Lunar Lake and Arrow Lake Edge, Intel has yet to develop a desktop APU series to go head-to-head with AMD's APU lineups. If you're familiar with Intel's graphics roadmap, you might have already heard about the upcoming architectures such as the Xe3 Celestial and Xe4 Druid. Even though Xe3 Celestial is coming to the Panther Lake mobile chips, it's supposedly also one of the core architectures on Nova Lake S. Xe4 Druid, on the other hand, represents the 15th gen architecture and is in an earlier stage of development, which has been obvious from the recent leaks. While the GPUs based on the Xe4 architecture won't likely arrive until late 2026, it's supposedly part of the upcoming Nova Lake S lineup. The central and most compelling rumor surrounding Nova Lake S is its unique hybrid iGPU architecture. According to reliable sources such as Jekin, Nova Lake S will integrate two distinct GPU architectures, Xe3 Celestial specifically for graphic workloads encompassing 3D rendering and gaming, and Xe4 Druid for display output and media-related tasks such as video encoding and decoding. This represents an unprecedented configuration for an integrated graphics solution. Xe3 Celestial is designated as the main GPU tile tasked with providing the raw graphics horsepower for primary 3D rendering and gaming workloads. When a graphically intensive application or game is launched, the Xe3 portion of the iGPU will undertake the heavy computational lifting. Surprisingly, reports suggest that Xe3 architecture employed in Nova Lake S will not be in the vanilla version. Leaker Bionic Squash indicates that it will feature several changes. The standard Xe3 is expected to first appear in Panther Lake mobile processors, and if these modifications indeed represent performance enhancements, they could be similar to the evolution from Meteor Lake Xe-LPG to Arrow Lake's Xe-LPG+, which notably introduced XMX engines. XMX engines are crucial for AI acceleration and Intel's Xe-SS upscaling technology, which can significantly boost gaming performance at lower resolutions. This suggests that the rendering capabilities of Nova Lake S are not just a generational leap, but also a version leap within the Xe3 family, further solidifying its potential to challenge budget discrete GPUs and provide a truly compelling integrated gaming experience. This gradual but aggressive refinement within a single architecture generation underscores Intel's commitment to significantly boosting its iGPU performance. While concrete execution unit counts for Nova Lake S Xe3 are not yet confirmed, Panther Lake is anticipated to feature between 4 and 12 Xe3 cores. Speculation suggests that Nova Lake S could potentially offer triple performance compared to the current generation of integrated graphics, possibly reaching the level of low-end discrete GPUs. This would mean a significant leap, enabling legitimate low-end 1080p performance for gaming directly from the CPU, which isn't currently possible on any Intel processor, including the Arrow Lake S. Coming to the Xe4 Druid, it is expected to be assigned the critical tasks of handling display pipelines and hardware-accelerated video encoding and decoding. This means it will manage everything from outputting the display to multiple monitors to rapidly processing video files for editing or streaming. A key highlight from the leaks is the claim by Bionic Squash that Xe4's media engine will be very nice and offer professional codec support. This means the Xe4 will support common codecs like AV1, HEVC, VP9 and the H.264 2.66 as well. This is a significant feature for content creators, enabling faster and more efficient handling of high-quality video formats. Although specific DisplayPort or HDMI versions for Nova Lake S Xe4 are not explicitly detailed, given that Xe4 is a future generation architecture, it is highly probable that Intel will aim for parity or superiority with competing solutions. For instance, AMD's RDNA 4 architecture already supports DisplayPort 2.1a and HDMI 2.1b, enabling ultra-high resolutions such as 8K at 144Hz and 4K at 240Hz. The very foundation of Nova Lake S hybrid iGPU is Intel's tile-based CPU architecture. This modular design, introduced with Meteor Lake, breaks down the traditional monolithic CPU into separate functional blocks or tiles. These are manufactured independently and then integrated into a single package. This modularity is crucial for Nova Lake S as well because it allows Intel to mix and match GPU configurations and different architectures as needed. The benefits of this approach are many. It provides significant design flexibility, allowing Intel to tailor different SKUs for various market segments and performance targets without necessitating a complete monolithic chip redesign. This also results in cost effectiveness and optimizes manufacturing yields. Less critical tiles such as the media engine can be manufactured on more mature and less expensive process nodes, while performance critical tiles can leverage advanced nodes. This will optimize overall manufacturing cost and improve yields by isolating potential issues to smaller specific tiles. This strategic process node diversification offers a substantial competitive advantage in the complex semiconductor industry. By utilizing both its internal 18A process node and TSMC's cutting-edge 2nm process for different tiles, Intel can select the optimal process node for each specific IP block based on the performance, power, and cost requirements. For a specialized media engine like Xe4, the TSMC 2nm process node could offer unparalleled power efficiency and transistor density, while the main CPU cores might be best served with Intel's own 18A. This diversification will also mitigate the risks associated with relying on a single foundry and will enable Intel to optimize its heterogeneous design across multiple areas. Finally, this modular approach will also enable faster innovation and will allow Intel to integrate newer architectures like Xe4 for specific functions, even if the full architecture is not yet ready for a standalone discrete GPU product. The most significant potential impact of Nova Lake S lies in its capacity to challenge budget discrete GPUs. The hybrid iGPU architecture, particularly with a powerful Xe3 rendering engine, is widely rumored to be capable of directly competing with and potentially replacing low-end discrete graphics cards. AMD's strongest APUs have already demonstrated impressive integrated graphics performance, even surpassing GPUs like the laptop RTX 4060. If Nova Lake S, especially in its higher-end SKUs potentially featuring 12 Xe3 cores, can deliver performance comparable to an 40 or 50 class card, it would offer legitimate entry-level 1080p gaming performance directly from the CPU. For many users, the idea of a PC without a discrete GPU that consumes less power, saves space, and reduces the cost is highly appealing. This could lead to a significant portion of low-end GPU market fading away as integrated solutions become good enough for a vast user base. It is important to note that iGPUs, even advanced ones like Nova Lake S, are highly unlikely to match the performance of high-end GPUs such as the 70 and 80 class cards anytime soon. The primary target of this disruption is the budget GPU segment. Nova Lake S has the potential to fundamentally redefine expectations for integrated graphics in mainstream gaming and content creation. AMD has been doing this successfully for a while now, and with Ryzen 9000G coming to the AM5 platform, Intel really needs something revolutionary to offer a similar experience. For gaming, the Nova Lake S appears to promise a significantly improved experience for casual and entry-level players, and with Intel's XeSS2 upscaling technology, it becomes easier to boost performance for free while retaining best possible visuals. For content creation, the dedicated Xe4 Druid media engine with its rumored professional codec support is a major asset for video editing, streaming, and other multimedia production tasks. Hardware-accelerated encoding and decoding will help to dramatically reduce rendering times and will offer smoother preview playback in applications like Adobe Premiere Pro. The key benefit here is that these media-intensive tasks will not burden the primary Xe3 rendering engine, ensuring smooth smoother overall system performance. Both Xe3 and Xe4, especially if Xe3 incorporates XMS engines, are expected to offer enhanced AI acceleration capabilities. This is increasingly important for modern applications, including AI-powered upscaling, background blur in video calls, and other complex tasks. The collaborative nature of this hybrid iGPU should significantly enhance multitasking capabilities and overall system responsiveness, providing a smoother and more efficient user experience across a wide range of applications. For a substantial segment of PC users, particularly those who do not require the absolute highest frame rates in AAA titles or professional-grade 3D rendering, the necessity for a discrete GPU has already been steadily declining. With Nova Lake S, a larger proportion of users may be able to achieve a satisfactory gaming experience, smooth 4K video playback, and accelerated content creation tasks without the extra costs. This could result in a noticeable reduction in the market share for low-end GPUs, and considering that AMD and Nvidia have already reached the sub-$200 GPU market, the value proposition of integrated solutions will become increasingly compelling for mainstream use cases. That said, despite the promising advancements, several technical hurdles must be addressed for Nova Lake S to fully realize its potential. iGPUs fundamentally share the system RAM and the CPU. The shared memory typically offers lower bandwidth and higher latency compared to the dedicated VRAM found on discrete GPUs. To mitigate this, high-speed RAM will be crucial for Nova Lake S to maximize its performance. However, the lack of dedicated high-bandwidth VRAM remains a fundamental bottleneck for iGPUs, especially as graphics workloads become more demanding. The shared memory for the iGPU typically has significantly lower bandwidth and higher access latency compared to the dedicated high-speed VRAM. This suggests that even with powerful Xe3 rendering cores, the overall performance ceiling for graphics-intensive tasks will ultimately be constrained by the available system memory bandwidth. While the adoption of high-speed DDR5 and LPDDR5X RAM helps, it remains a shared resource. Therefore, the revolutionary impact of Nova Lake S on high-end gaming and professional rendering might be limited until a solution like on-package memory becomes standard for desktop platforms. This represents a long-term architectural challenge that even Nova Lake's innovative hybrid design cannot fully overcome without a fundamental shift in desktop memory subsystems. On the software side, driver optimizations represent perhaps the most critical hurdle for Nova Lake S success. Seamlessly switching workloads between Xe3 and Xe4, ensuring that applications correctly identify and leverage the appropriate engines, and optimizing overall performance across both architectures will depend entirely on robust and mature software drivers. Intel has faced well-documented driver challenges with its Arc GPUs and is still struggling to catch up to AMD and Nvidia. However, this hybrid approach adds another layer of complexity. While the underlying hardware design is undoubtedly advanced, a poorly implemented software layer can severely negate its advantages. If Intel can deliver highly optimized, stable, and intelligent drivers that can effectively utilize both Xe3 and Xe4, it will unlock the architecture's full potential. On the opposite, if software limitations persist, the groundbreaking hardware won't reach its full potential, which will negatively impact user experience and market adoption. It is important to remember that Nova Lake S is still some time away, with a rumored launch window in the second half of 2026. This extended timeline allows Intel to continue refining the architecture and addressing the technical challenges, but also means that these are still rumors and subject to change. So that wraps up today's video. I hope you enjoyed it, and if you did, then do share your thoughts on Intel's new approach for the Nova Lake S in the comments. Also, make sure to subscribe if you don't want to miss such videos in the near future, and I will see you in the next one.